Okay. I have not had anybody say anything to me in the chat as far as an answer goes, so I'm assuming that we're still all working on it or that we are stuck somewhere. So first thing I want to do is put both of these equations into slope-intercept form. Are either of these equations in slope-intercept form right now? Nope. All right. So let's take the top one. We'll put that one into slope-intercept form first. X plus 2y equals 2. Remember, our slope-intercept form is y equals mx plus b form. What do I need to do to x plus 2y equals 2 to put it into mx plus b form? Minus x, absolutely. All right, we're going to subtract x from both sides. So that would give me 2y equals, I want to keep the x in front because when I look at my slope-intercept form, I have x with its coefficient right after the equal sign there. So I'm going to write minus x because the x has a minus in front of it. Would the 2 be a plus or a minus? Plus, because that's a positive 2. Okay. Almost in slope-intercept form. I don't have the y all alone yet. I still need to get rid of what? Yes, absolutely correct. We're going to divide both sides by 2. Right now they're being multiplied. And when we divide both sides by 2, that means I have to divide each piece over there by 2. So that is a negative 1x. I have to distribute that and divide it by 2. And then I have to distribute 2 divided by 2. We distribute with division just like we distribute with multiplication. Will either one of those fractions simplify further? Will either one reduce? Yes. 2 divided by 2 is going to reduce down to what? Yes, there we go. Plus 1. Perfect. So there's the first line that we're going to graph. Here's my y-intercept. It is going to be at the point 0, 1. That's what puts it on the y-axis right there. And then I have my slope right here of negative 1/2. So what way do I move according to the slope to get my next points? Give me words like up, down, left, right. I see down 1 and right 2. Yes. So I'm going to go down 1 and right 2, down 1 and right 2, until I can't go any further. And then I can back it up and go the opposite direction, keeping it all in a perfect line. I want to get as many points as I can. That increases my precision, especially if you're graphing this on your own paper at home and you don't have graph paper. There is graph paper that you can download and print if you have access to a printer. If you don't have access to a printer, you could always pull up a picture of graph paper and you could screenshot it and then annotate on top of that using either your computer or your iPad or your phone or whatnot. Thank you for letting me know that. All right. So now second equation, we need to also take this one and put it in slope-intercept form. So I'm going to bring that around over here. Negative 6y equals negative 3x minus 18. Is this one in slope-intercept form? Let me know in the chat, yes or no. Is this one in slope-intercept form? No. Okay. So what do I need to do to get it in slope-intercept form? Divide by negative 6. This is being multiplied by -6, so I'm going to divide everything over here by -6. Don't forget, that means we need to distribute our division. So I have -3 divided by -6, x, and then -18 divided by -6. Will either one of my fractions reduce? Yes. Does the first one reduce? -3 over -6. Both of them do. Yes. Okay. So -3 over -6 reduces down to what? +1/2. Awesome. So I have a +1/2 x. This one over here, I have a -18 and a -6. How will that reduce? +3. There we go. So +3. This is our second line that we're going to graph. Here's my y-intercept at 0, 3. So right here. And then my slope of 1/2. Last time we went down 1 and right 2. Will I do the same thing this time? No, what am I going to do? Up 1, still right 2. There we go. So from that y-intercept, up 1, right 2, all the way to the edge of the graph, turn it around, make it go backwards. Oops. There we go. Grab your straight edge. The more points you plot, the more precise your graph will be, which is really important if you're trying to do this without graph paper, especially. All right, so there's my system of equations. How do I find the solution? What am I looking for on the graph? How do I find my solution? What do I want to see on the graph? And I will know that right there is the solution to this system, where they intersect. Absolutely. So right here, this is the solution. What is that ordered pair? Awesome. Thank you, Belzy. That ordered pair is -2, 2. Remember, when we write an ordered pair, it's always the x part first and then the y part. So we describe any left-right movement first, and then we describe any up-down movement from the origin. Awesome. Do you guys have any questions for me about graphing a system to find the solution? All right. If you think of any questions, please feel free to type them into the chat. Even if I've moved on to something else, I am always happy to circle back and answer questions for you. I want to look at a system, and they've given us an ordered pair, and we want to determine if this is a solution. We're going to do that by subbing this in. So I'm going to put the -3 in the place of x. I'm going to put the -1 in the place of y. It has to work in both equations, or else it is not a solution. If it works in the first one, but not in the second one, it's not a solution. It has to work in both. All right, so let's try this first equation right here. Have -9, and then in the place of the x, I'm going to put -3. -4, and then in the place of the y, we're putting in -1. equals negative 38. This is kind of like a check. Those of you that had me last semester, when we do our checks, we are not allowed to cross that equal sign at all. Cannot cross it. We're going to simplify the left-hand side, and we're going to see if it gives us what's on the right-hand side. So what can I do on the left-hand side to check this, to see if this is a solution? Tell me what I can do. Multiply. What do I want to multiply together? -9 and -3. Okay. What do I get when I multiply the -9 and the -3 together? I get a positive 27. Beautiful. What else do I do? Oh, then -4 and -1. What do I get when I multiply those together? 4. Is that going to be a positive 4 or a -4? Positive. So that means I have a plus sign in between these two instead of a minus. What is 27 plus 4? 31. Thank you, Griffin. What did I have on the other side of the equal sign? Good thought. Good thought. I do want to clarify just a little bit because I love the way you're thinking. Yeah, we had a -38 on the other side. Thank you, Elijah. These two are not the same. And so what that means is that -3, -1 is not a solution. This is not the same thing as no solution. It doesn't mean that there isn't a solution. It just means that that's not it. Kind of like if you're walking around and somebody says, hey, is that your sister? And you're like, no. That doesn't mean that you don't have a sister. That means that that person is not your sister. In this case, this ordered pair is not the solution. But that doesn't mean that a solution does not exist. Hopefully that clarifies just a little bit. All right, I want to do another one just like this. I'm going to put up a system of equations and an ordered pair, and we're going to check to see if it is a solution. All right, I want you guys to copy down the system and the ordered pair. Here it comes. All right. -6, -2 is my ordered pair. And my two equations are -3x plus 2y equals 14 and -6x plus 3y equals 30. Let's go with the top equation first. What am I putting in the place of the x? -6. Awesome. Here's my x. And then I'm going to recopy the +2. What do I put in the place of the y? -2. Thank you. And then I recopy my equal sign and my 14. Just like before, cannot cross the equal sign. We're going to simplify the left. We're going to see if that gives us what is on the right. Tell me what to do on the left. What should I do on the left? Multiply. What are we multiplying together? -3 and -6. What do I get when I'm multiplying -3 and -6? 18. What do I do next? Yes, absolutely right, Anaya. We're going to multiply the 2 and the -2 together, and we're going to get -4. So I end up with -4. What is 18 minus 4? 14. Thank you, Griffin. What did we have on the other side? Same thing, 14. These are equal. Am I done? Can I say that this is a solution? Not done yet. It works here. Now check the other. Okay. So -6, and we're going to put -6 in the place of x, plus 3, and we're going to put -2 in the place of y. And if that gives us 30, then this is a solution to the system. What do I get on the left? When I do these two multiplications, what do I get? Tell me each piece. I want to write down the addition or subtraction problem here. Yes, thank you, Griffin. 36. That's not very clear. Go. 36, and what else? Plus -6. Absolutely right. When we add a negative number, like this right here, that's exactly the same thing as subtraction. So that's the same as saying 36 minus 6. I love that you wrote it like that. What is 36 minus 6? 30. Cool beans. Because on the other side, we had 30. What does that tell me about this ordered pair? Yes, this is a solution. -6, -2 is a solution. All right, nice work so far. Okay, I want to look at a situation where I have two graphs and I want to write the equations from those two linear graphs. We're going to write the solution and the equation. So we're going to go backwards from what we did in the first problem. All right. Let's name our solution first. What is the solution to the system? -2, 2. Right there is my solution. Okay. To write the equations for the graphs, here are the steps that I walk through. First, find the y-intercept, because that'll be your b value. Then find another point or ordered pair. You're going to count your rise over run to find the slope, which is m. Couple things about that. Up, if you go up as you count between those, rise is positive. If you go down, your rise is negative. If you go right, when you do your run is positive. And if you go left, when you count between them, your run is negative. Then we will write our equation. You guys ready to start? You want to do the red line first or the blue line first? Red or blue? Red, sounds good. We'll do blue second, but red is just the first thing that I saw pop up in the chat. Okay, so where is my y-intercept on the red line? 4, beautiful. So right here is my y-intercept. B is 4. Give me another point that I could use so that we can count between them. Give me another ordered pair. Anywhere on that graph where you could put a dot down, -1, 3. Absolutely, we can use that one. -1, 3. So we're going to use this point right here, and I want to count between them. We could have used 0, -4. Absolutely. You can pick any of the points that are on that line and count between them. Do you want to start at the y-intercept, or do you want to start at -1, 3? Because you got to tell me where we're starting from so that we can count our rise over run. Start at the y-intercept. Sounds good. Okay, I need rise first. So I need to go up or down first. So from the y-intercept, do I go up or down to get to this other point? I go down. I go down how far? I go down 1, yes. Down 1. So that means my numerator is going to be a -1. And then I need to do my run from the bottom of this arrow right here, because I shifted down 1. Do I go left or right to get to the point that we have marked? Left. I go left how far? 1 point. So left 1. If I go left, do I put a positive or a negative, Belzy? We'll get there in just a second. If I go left, is that a positive or a negative? Negative. Okay, so down on the bottom, I need -1. Now I'm going to look. My rise over run. Can I simplify that at all? Does that reduce? Yes. What does it reduce to? Reduces to a +1. So here is my slope. Belzy, does that help you understand a little bit better? Awesome. Okay. So the red line, it has the equation y equals 1x plus 4. Or you could just write that as y equals x plus 4. Because if our coefficient is 1, we don't have to put it there. So far, so good? Let's do the blue line next. Where is the y-intercept on my blue line? -4. Thank you, Griffin. Y-intercept, so B is -4. All right. I need another point so that I can count between these. Give me any other point where you could write down the ordered pair. I need another point that's on this blue line. Thank you, Anaya. -1, -1. We could use that. I'm kind of surprised that nobody said we could use the solution. We can use that for both of the lines if we want to. Again, it does not matter which point you pick on the line. You just have to pick something so that you can count between them. All right. You guys want to start at -1, -1, or do you want to start at the y-intercept to do our counting? Do you want to start at -1, -1, or do you want to start at the y-intercept to do our counting? Y-intercept sounds good, Soraya. So we need to do the rise first. To go from the y-intercept to this other point, do I go up or down? I'm starting at the y-intercept, I go up. How far up do I go? Close. Count one more time for me. I go up 3. So what is the numerator that I'm going to put in for the rise? Do I put +3 or -3 for my rise? +3. Beautiful. And now I need my run from the end of this arrow right here to get to the point. Do I go left or right? Left. And Soraya, I see that you saw left 1, and so that's going to be a -1. Absolutely correct. Left 1. So I'm going to have a -1. Can I reduce or simplify that fraction? Yes, what am I going to get when I simplify it? -3. Love it. So this right here is the slope for my blue line. Beautiful. In the chat, please type in the equation for the blue line. Write it in y equals mx plus b form. I'm gonna wait for a couple other people to give me their answers as well. Send it to me in a direct message so that only I can see it. Soraya, that is correct. Griffin, awesome. Belzy, that's correct. Let's get at least one more person to answer. Close, Elijah. You just missed a sign. Anaya, same thing. You just missed one sign. Go back and look at what our slope is. Very, very close. There you go. -3x, because when we simplified our slope, we had 3 over -1. So that simplified to -3. -3x minus 4. Nice job, Elijah, as well. Usually, if we have something over 1, when I go to graph it, I want to put whole number slopes over 1 so that I can do my rise over run. When I write it in an equation form, I usually want it to have just a whole number if that's possible. If the numerator was -3 and it was +1 on the bottom, would it still simplify to -3? Yes, it would. Good question. Here's another thing, actually, while we're on that topic. Let's pretend for just a minute that we got something that was, say, up 2 and left 3. That is exactly the same as down 2 and right 3. And that is exactly the same as if I take that negative sign and I move it out in front of the fraction. And I don't put it with the numerator or denominator. Soraya, usually, yeah, you can pick which one you're going to make negative. Usually when we have a negative as part of our fraction, you almost always put it out in front of the fraction, or as kind of a default, we would usually put it up on the top if you had to pick. So if this is what I found when I was counting, I would probably type it into Canvas like this. Because in Canvas, it's really hard to tell the difference between like this one and this one, because I would start with the negative either way. But if you were doing it on paper for me, all 3 of those have the exact same meaning. I would count all 3 of those the same. You type first in Canvas and you have the right answer, but Canvas counts it wrong, I'll go in and give you full points for it. I won't count off. As long as you have the right numbers, I don't care where you put the negative sign, whether it's top, bottom, or out in front. Great question. Great question. Okay, with our last little bit of time, I do want to talk about graphing inequalities. It's very similar to what we've done with graphing equations. When we graph an inequality, we're going to use a dashed line if it just has a greater than or a less than, to show that the points on the line are not actually solutions. We will use a solid line if it has the or equal to on it to show that the points are solutions. We have to have our equations in slope-intercept form for this next part to be true. We will shade above if the inequality is greater than or equal to. And we will shade below if the inequality is a less than or equal to. So I want to graph these two. And then we're going to talk about solutions. So top inequality right now. Is this one in slope-intercept form? Sweet. That makes my job way easier. Here's my y-intercept. It's at 0, 5. So I'm going to put that point down. And then my slope is -3. So I'm going to call that -3 over 1. That tells me to go down 3 and right 1. So from my y-intercept, down 3 and right 1, down 3 and right 1, until I run out of space on my graph. And then I turn it around and I go backwards as far as I can, which is just one line or one dot here. Will I do a dashed line or a solid line here? Will this be dashed or will this be solid? Dashed, yes. Right here, this is going to be dashed. So I'm going to use my straight edge and I'm going to do my best to sketch a dashed line. Straight edge is only so good. All right. Forgive me for this. It's really messy. My pen is just being really difficult right now. Would I shade above or below that line? Shade above or below? Below, yes. So here we go. I'm going to shade over here. And now I want to go and do the other line. Is this other line in slope-intercept form? No. I need to start off by putting it into slope-intercept form. So tell me what I need to do to get this in slope-intercept form. Minus 4x. So I'm going to minus 4x from both sides. Because I want it in slope-intercept form, I have to make sure that that minus 4x ends up right after my inequality. The 12 is positive, so I have plus 12. What next? Divide by -2. Is there anything that I have to watch out for when I do division here? Switch the signs. What do you mean by switch the signs? I like it. What do you mean by switch the signs? Turn it around. Yeah. This inequality right here has to flip the other way because we divided by a negative. Now I'm in slope-intercept form, so now I can go in and graph it. So I'm going to start off with my y-intercept at 0, -6. So down here, my slope is 2 over 1. So up 2, right 1. Up 2, right 1, up 2, right 1, until I run out of space on my graph, and take it backwards as well. Dashed or solid on this? Solid. And shade above. Yes. According to this inequality right here, we're doing solid and shade above. I'm going to grab my straight edge. My straight edge is much better with solid lines. I'm going to trace through these points. We're going to shade the above side. So that's going to be over here. And the solutions are in the double shaded space. Is the point where these two cross a solution? Is the point where those two cross a solution? No, not a solution, because one of the lines is dashed. If both lines were solid, then it would be a solution. If one of the lines is dashed, then where they cross is not a solution. They have to both be solid for it to be a solution on an inequality where they cross. All right, you guys have homework that's due for me tomorrow morning on graphing systems of equations and inequalities. Please work through that. If you get stuck at any point, if there's anything that you don't understand how to do on the homework, or you get something wrong and you don't know why it's wrong, please send me a message in Canvas and we will work through that together. I hope you guys have a fantastic rest of your day, and I will see you tomorrow.